So the first thing that I noticed looking at this network is that it's horrible and there's just all kinds of stuff going on. And so I need to figure out where I'm going to start. And I need to figure out, what's going to happen and when. I've got a couple of components in there that, they do different things depending on, what they see or what else is going on in the circuit. So I've got two power supplies. I've got resistors all the way around the outside, and then in the middle I've got a capacitor and I've got a diode. Now the capacitor's not, there really isn't any information given, so I just have to think about what the capacitor rules based on what is given. So it's a DC circuit. There's nothing about the capacitance given, so I can't really, there wouldn't be any way to do any time constant or charge analysis on that capacitor. So I really have no choice but to assume that it has a full charge. So I think that's what I'll do. I'll just, imagine this circuit's just been running and I walked up and looked in and saw this circuit. So we'll consider that capacitor to be a full charge, which means to DC, C1 we'll just say full charge. Basically C1 will have no current flow and it'll just look like a big open. So whatever voltage is available to it on points A and B, it will, if you were to go measure it, it would have that voltage present, and it would just be, so I AB equals 0 amps, and VAB is unknown. So C1 has a full charge, or we'll assume it has a full charge because there's not really enough information given to do anything else. So we'll consider C1 to be fully charged, and therefore it's an open. There would be zero current flowing into it, and its voltage would be whatever is available to it between points A and B. So there's something to figure out. And so we're just gonna, for now, let's just ignore C1 and just pretend it's not there, because we'll just treat it like an open, which essentially if we removed it, it would be the same. Okay, now that diode D1, the symbol is a Zener diode, but 9 volts. Now commonly people will see that 9 volts and they'll be like, oh well, it's 9 volts. Well, that may not be the case, so we need to decide or analyze the circuit, figure out what the diode sees. So what is the voltage at C, or between C and D, and does the diode have enough voltage to do anything? So if it was forward biased, which would mean plus on the anode and minus on the cathode, well, a Zener diode is just a silicon diode, and so it would have a forward bias voltage of 0.7 volts. So if there was at least positive 0.7 volts between C and D, that diode's going to be forward biased, and it will hold that 0.7 volts. Now, if it's reverse biased, which means there's a minus on the anode and a plus on the cathode, if it's reverse biased, then we have to consider that it is a Zener diode, and if that reverse bias voltage is greater than the rating, which is given as 9 volts, then that diode's going to react and avalanche and start allowing as much current as it needs to maintain that 9 volts, negative on the anode, positive on the cathode. So the C to D voltage would be negative at that point, and if it was greater than, in this case, 9 volts, then that diode will reverse bias, will avalanche and hold that voltage to be 9 volts. In this case, VCD would be minus 9 volts. Now we don't know what that diode is seeing, so let's we're going to have to figure out a plan to figure that out. Now, if that diode was sitting around on the shelf, basically the conditions have not been met for that semiconductor to be a conductor. So we'll consider that it is an open or infinite resistance until it's provided with some conditions where it will allow current to flow. So for now, I'm going to treat that as an open until I know what the rest of the circuit is providing for it and what it sees, and will it bias either forward or reverse, or will it just sit there and remain an open. Now there's three possible scenarios. The C to D voltage is such that it will forward bias, and then the diode will hold it to be 0.7 volts. The C to D voltage is reverse biased, and that diode will hold the 9 volts. And the third scenario is there just isn't enough voltage in either in forward or reverse bias to cause that diode to allow any current flow, and so it will just remain an open. So for now, I'm just going to consider C1 and D1 as an open, and I'm going to analyze that circuit as if those things are just not even part of the circuit. They're, the moment the power was applied, they were opens, and so we'll just consider them to not be there, see what the rest of the circuit is providing and what they would react to, and then we'll go from there. So first things first, I'm just going to ignore those two components, and I'm going to maybe do a redraw with them completely gone so that I can just really ignore them. And we'll create a scenario that shows what voltages would be applied from A to B and from C to D, and then we'll go from there.